As Salome said, my name is Laith Walk. I'm a registered landscape architect with the Australian Institute of Landscape Architects and a partner in Vidaus Landscape Architects. We've been established in Dubai since 2004. And over the last 10 years, I've been working and living with the climate of the UAE. It's taught me some great lessons about landscape design in this part of the world, which is very different to landscape design in other parts of the world, because we have a very unique climate, and I'm sure you're all aware of what that means. But the experience of living with the UAE climate has really sharpened my appreciation for plant life, and this strikes me the most strongest. It does sharpen our awareness of the importance of plant life, and there's a really important connection between plant life and animal life and us. And when I leave the UAE and I go to a country where it's very verdant and there's plant life everywhere, I get the sense that I'm being supported. And there's a hypothesis called the biophilia hypothesis, which talks about the relationships between humans and nature and how that important is for many aspects of our life. So greenery improves quality of life, and even in small amounts. In particular, in a place where there's such a lack of greenery, a small amount can make a big difference. This is one of my favourite gardens of the UAE, and to me it's a symbol of nature doing its thing in spite of everything that we do around it. I call it the rambunctious garden, and it's just a small patch of greenery, a little rebel in an urban environment. But this is taking that little rebel and it's expanding it, and it's using that greenery in a different way to what we are most used to using it. Landscape has become a very ornamental and perhaps a decorative treatment, but there's much more to landscape than ornament and beauty and decoration. Landscape can really help to improve the quality of life, particularly in the city where we are. And what you're looking at here today is a city not far from here. It's across the Gulf. It's in the middle of a desert plateau. They have extreme heat, as we do, and the way that they have planted the streets really does make such a major difference to the comfort levels on these streets. I visited Isfahan, this is Iran, in the middle of summer. Any street without trees was unbearable, but these streets, which were planted a long time ago with very, very dense tree planting, were quite comfortable. And this is an example of the green infrastructure approach, where trees have been planted not just for their visual effect, but in order to enhance the comfort of a city. So I've touched on trees being good for beauty, trees and plants, good for comfort. They're also good for business, from a very small scale to attracting people to your golf course or attracting people to your hotel, to attracting skills and expertise to the city. And what a great connection we have with Dubai striving and the rulers of Dubai, pushing Dubai to become a hub of skills, and expertise, which it has become, and it's becoming stronger. And landscape has a very important role to play in that mission, because landscape improves the quality of the living environment, it improves the quality of the life, and people with high skills and high expertise choose quality of life when they choose places to live. So the more landscape the city can provide, the more it's able to attract skills and resources, and the more Dubai is online with achieving its mission of being that hub, that regional hub that we're becoming. Other than being good for business, it's also an element of the art of survival. And the art of survival, I've borrowed this title from an article written by a landscape architect who talks about exactly how landscape and green infrastructure has been used traditionally in order to help us live in a more comfortable way. And what we're talking about now is sustainability. One example of that, which everybody will be familiar with, is the term urban heat island effect, which is quite interesting because cities around the world today are talking about urban heat island effect, and they're actually recording and studying how trees and plants are reducing the urban heat island effect, which is becoming much more important today with the global warming phenomena taking place. Trees do cool the city, that's been proven. However, trees also need water, and water is a precious resource. We have a thought that is going around, and it's connected with the sustainability rating schemes, and it's a main theme of what I'm going to be talking about today. It's about using less water, and it's about the idea of using less water to create landscapes that use less water. Well, I'd like to challenge that a little bit, and I'm going to sort of try and turn it on its head so that we can look at landscape and the idea of efficiency from a different angle. So less trees, less water. Okay, that's quite a simple way of reducing water consumption. But is it really the most sustainable path? I mean, that's an important question. Does anybody here think that they could answer that question? Does anybody here think they know somebody who can answer that question? Okay, so I think there's some research that needs to be done in this area because I think it's a really important question. Well, we know about urban heat island effect, but in Abu Dhabi, what we actually have is an urban cool island effect, which is inversing what happens normally in cities. The urban heat island effect is caused by the pavements and the surfaces in a city absorbing more heat, thus making the city more hotter than the surrounding areas, and that's the common pattern for cities all around the world. Except they've just completed a research on Abu Dhabi, and what they've found is it's reverse to what happens in most cities. Abu Dhabi city is actually cooler than the surrounding areas, and what we have here So what we have here is the cooler temperatures are the green areas. The next cooler temperature is the yellow. And the little spots of orange are where it starts to get warmer. So you can see that Abu Dhabi Island and Abu Dhabi City is actually cooler than the area outside of that. Now the image on the left is looking at the different types of surface coverage in Abu Dhabi City. The green represents vegetation. The red represents built-up area, and the yellow represents the sand. So what you can see is there a correlation between the areas where you have vegetation and the areas which are cool. And what they found was that because of the amount of vegetation that's in Abu Dhabi City, the city is actually cooler than the desert environment. And when we talk about sustainability, one of the biggest challenges that we have in this city in terms of energy consumption is the summer requirements for keeping the city cool. Does anybody here know how much is reduced by 1 degree cooling of the city in terms of amount of electricity saved? I think that's a very important study to be made as well. The suggestions that using less water is more sustainable, that's the suggestion, and that's the paradigm which I would like to challenge. It's promoted by a lot of popular sustainability rating schemes, and a lot of these rating schemes are actually produced by countries very different to the country that we are in today. Let's consider some differences. A situation where irrigation is using drinking water. On the one hand, we're using irrigation with drinking water. That's competing with water which should be available for drinking. And that's the context that a lot of the sustainability rating schemes are coming from. Let's now consider, on the other hand, irrigation using recycled water. That's what we have here today. Let's consider a citywide recycled water network. How many cities in the world have that? In the developed countries, that's a very rare thing. And I think we need to identify that that's a very unique piece of infrastructure that this city has. In fact, in terms of water scarcity, we may have a water abundance and a water oversupply. Now, I'm going to talk about this in a very careful way because we will always need to use water very carefully, but I think we need to challenge the paradigm that we never have enough water, because in actual fact, sometimes we have more than enough. This is a shot of an outfall in Sharjah. This is treated sewage effluent going into the Gulf. Who says we don't have enough? Surplus. A study was made on the creek in Dubai. Interestingly, the largest single input of fresh water into that creek was coming from the Alawir sewage treatment plant. 100,000 cubic metres a day into the lagoon. Does anybody have an idea about how much water that is per day? Craig's nodding. Craig has an idea about how much water that is per day. It's a lot of water, and you could do a lot of things with that amount of water. But that's only one outfall. There are other outfalls in the city as well. How much water is getting discharged without going into green infrastructure? The goal, to make use of every drop, not to waste any. We're not going to just talk about blindly reducing the amount of water we use for landscaping, because I don't think that's right. I think we need to look at how we can use every single drop that we create, that we recycle. The reason that we have wastage is that we have peaks, troughs and redundancy. In the summer, we have a low population, and the population produces the wastewater, which is what's used for irrigation. In the summer, we have a high demand, we have a low supply. In the winter, it turns up the other way around. The demand goes down and the supply goes up as more people come back into the city. So we have this problem of supply and demand. I mean, what are we going to do with this extra water? How can we design the system so that it functions in the harshest time during summer and without wasting in the winter, without wasting a single drop? How do we manage variations between supply and demand? How to prepare for times of shortage? Would anybody like to make a suggestion? There's no silly suggestions, by the way. Well, in fact, there's no silly suggestions that I haven't made, because I've made plenty. And that's part of the process of trying to look at things from a different angle. So how do we prepare for times of shortage? How can we stop the water being wasted? Does anybody have a thought on that? Let's say we live in a very cold climate, and during the summer we have a lot of food, and we know that during the winter we don't have a lot of food. In fact, there's no food to be got. So what do we do during the summer in order to prepare for the winter? Like a squirrel, yeah? We'll take the food and we'll put it aside. We'll store it. This is the way that we can manage the peaks, the supplies. You know, we've got a lot in summer, we don't have any in winter. How are we going to do that with treated sewage effluent? It's a lot of water to try to save over the entire summer period, much more than 100,000 cubic metres per day. It's massive. Well, increased storage capacity, which is what I've just mentioned, is one method. There are many, and typically with green infrastructure, there are many different ways to improve the sustainability of a system. As Craig has already mentioned, it's not just one magic bullet. There are many different ways. We only find those ways by looking at the problem from a particular angle. Typically on a project, I'm a landscape architect, we design for 1 day's storage. Yeah. Usually that's quite a big tank and there's a cost associated with that. But we can't imagine 1 day's storage for the entire city, let alone one summer's storage. That's a massive tank. Yet we still need to store in some way. How can we do it? Does anybody have an idea? You guys are making me feel really good because you're making me feel like it's my brilliant idea, but when you really think about it, it's quite obvious. One way of storing water is through a material in the soil, actually. The soil could be a key to this problem. How to store water. Our soils are so poor at storing water. Water just flows through. They're free-draining soils. Yeah. How much soil do we have? What's the volume of soil supporting the green infrastructure in the city? It's a lot. It's a lot of soil. It's a massive amount. It's a huge volume. So here we have a huge volume of a medium that can store water if it's the right quality. And we have a huge volume of water that we're trying to store. This is the silo. So this is the idea about storage. How to create a silo out of soil. Silo, soil, kind of. They use all the same letters. It's almost the same thing. One possibility is to increase the water holding capacity of the soil. And there are many products out there that do that. What I'm going to talk about today is a product that we did a small case study on, and that product is called Zeoplant. Now, I'm a consultant, and I don't endorse any product as such. However, in this particular case, Zeoplant and the contractor gave us access to the objective data that enabled us to make a comparison, which I'm going to present. And one of the things that struck me during the site visit, during the case study, was the information that on this particular project there was a water shortage, no water actually, forget water shortage, of 22 days with no irrigation. 22 days with no irrigation in most cases means that's it, all over Red Rover, no green plants. They reached temporary wilting points, they had very few mortalities, so that triggered a spark in my mind. Water is being stored in the soil. These two projects that we went to do a case study, Motor City Uptown and Motor City Green Community. So here we have Green Community, here we have Uptown. The interesting part about these two projects is that they are maintained under the maintenance of the same contractor, Gulf Landscape and Irrigation. The other interesting part of these two projects is that one used Zeoplant at the installation and the other did not. So we have a great laboratory here in order to assess objectively what this material is doing with the soil and with the water savings. So here are some very basic numbers. We look at the Uptown and we've got Green Community. So the first numbers that you're looking at is the amount of Zeoplant per tonne that was estimated for Uptown, because remember that Uptown did not actually use the Zeoplant in the end, it was never installed, and Green Community, which did use the Zeoplant. So in Uptown we had 481 tonnes, which is amount of Zeoplant which could have been used in the project, and on Green Community we have 567 tonnes. So roughly about the same. What those numbers indicate to us, it indicates the amount of soil that's in both of those projects. So as a ratio between Uptown and Green Community, we've got 1 to 1.8 or 1.18, 1.2, so almost the same, okay? What's the daily water volume? Now this is very interesting. On Uptown we've got 5,300 cubic metres per day. On Green Communities we have 1,200 cubic metres per day. That ratio is quite different from the 1 to 1.8 or 1.2. So if Uptown is using on a ratio 1, Green Communities is using 0.24. We have a situation where we have roughly the same two developments. One is using 25% of the amount of water that the other is. I think that's pretty amazing, really. But I don't think that's the most amazing thing about the project. What I think is the most amazing thing about this is the actual run times. The run time for the irrigation system on Uptown is 17 hours, and the run time on Green Community is only 4. This is the runtime chart for the green community, and you can see the 4 hours, and there are the runtimes for the uptown. So what you can see here, the red arrows are pointing to the windows where the green community is getting irrigated. The yellow arrow is pointing to the 12 to 3 period during summer, which they do not irrigate at all. As I've mentioned, 22 days without water, only temporary wilting point. Another aspect which indicated the soil storage capacity was that there's a more homogeneous growth. So we have plants with different water requirements living side by side. Normally one of them dies. The one that doesn't get enough. We have a plant on the one hand that needs a lot of water. We have a plant on the other that doesn't need much water at all. So what do? Do you try and satisfy the guy who doesn't need a lot, or do you try and satisfy the guy who needs too much? You can't please everybody, and whichever one you're going to try and please, the other one is going to suffer. There were plants with this kind of different requirements in the green community. However, they were living side by side quite happily. And the reason for that is the water was going into the soil and it was being saved in the soil, not waterlogging the plants, so that the plants could take that water when they needed it. So it's like having water on demand for the plant, yeah? Which is an interesting process, and it's really quite amazing when you look at plants and you see that as long as there's water in the soil, the plant is going to take from that. If you try and do that by applying the water every day, you're going to waterlog the soil and that plant will die. Other benefits of the run times: if we use a material which we can store water in the soil, we're reducing electrical power consumption because the pumps are only running much less. We had 17 hours, we had 4 hours. We're reducing the amount of labour and supervision. If we're running the pumps for 17 hours, we have guys supervising that. Only 4 hours, we have guys only supervising 4 hours. When we put too much water on the soil, it's leaching the fertiliser out of the soil. So in the green community, there was a 40% saving on the amount of fertiliser that was being used just because we're using less water. And there's less downtime on recreational open space, and this is something that would be prime at the top of Craig's mind as a golf course manager. Other than that, it also affects the root growing patterns of trees and provides a much stronger tree and stronger plants. The roots go deeper. Other benefits which I never really thought of myself, but when I visited the development and was talking with the contractors who maintain, because they get a lot of information directly from the residents, mostly complaints, but where they need to water more, they have moisture on the surface. That moisture is used by the fly population. It's great for the larvae to lay eggs, yeah? So if we're putting water every day, we're creating the pristine environment for fly population to multiply, yeah? So less fly population has been, it's an anecdotal evidence, but the residents are sort of complaining bitterly on the one hand, and on the other hand, they're not getting any fly problem at all. And another aspect is water seepage. If you continue to put water every single day and it's seeping into the soil, there are at times, it will go into areas where you do not want. And I'm not sure if anybody has noticed the road that goes on the Palm Jumeirah. Anybody driven along the crescent there, Palm Jumeirah? Has anybody driven along the crescent? No? Come on, somebody here has driven along the crescent, Palm Jumeirah. Anybody? I bet there has been. Anyway, I've driven along, I'm going to admit it, okay? I have driven along the crescent at Palm Jumeirah, and I'll tell you what's happening there. They have a grass bank which goes down to the road that runs along the crescent, and the road surface itself is dipping down. There's actually a trench that's being formed in the road surface. Why is that happening? Anybody like to make a suggestion? Well, it's happening because the water is getting applied to the grass every single day, and it's seeping underground and it's going underneath the road, and it's making the road soft, and all of the traffic which is going over the top is pushing the road surface down. Okay, so here we have a case where a material that enables us to use less water is actually going to save on our road surface. In talking with the supplier of the material, they estimate a return on investment of the product between 2 to 3 years. That's savings on water, electricity, fertiliser and labour. And to wrap up, I would just like to reiterate the main points of today. Trees and plants, we need them, for sustainability. The question, is less more sustainable? The reality, we have a city-wide network of recycled water. We also have peaks and troughs, which I believe is the main problem, and not necessarily not enough. And we have the concept of increasing storage capacity to increase efficiency. So that's enough from me. If anybody has any questions, please feel free. You're welcome, and I don't bite. Even though my name is Laith. Any Arabic speakers in the audience? Shuyani Laith. The lion. Yeah, true. Lion, but I don't bite. Except when I'm hungry. So if there are no questions, I'd like to thank you very much for your time. I appreciate it very, very much. Again, my name is Laith Walk for Dow's Landscape Architects. If you would like any more information or details, or would just like to talk about what we've discussed today, you're welcome to contact me. This is my mobile number, and that is my email address. Thank you very much.